Hello, everybody. I'm going to continue on today with some additional probability notes. I'm going to talk about conditional probability. And so we're going to derive this rule using what we already know, which is the multiplication rule. So I'm going to remember, let's recall the multiplication rule in probability. So the multiplication rule says, in order for us to determine an event to happen in some type of sequential order, so let's say the probability of event A happening and then event B happening is determined by the product of the probability of event A times the probability of event B after event A, or given that event A took place. So what I'm going to do is I'm going to derive now conditional probability. So if I want to solve for this guy, I want to isolate this guy, what's going to happen is right here between these two, it's a product. So in order to undo that, I must do the inverse operator of that, which is division. So I'm going to divide both sides by the probability of A. Bum, bum. So now I recognize that conditional probability, or the conditional rule, indicates that the probability of event B given event A is equivalent to the probability of event A and B divided by the probability of event A. So if we notice here, this is called conditional probability because in here, the condition is given that A occurs. So this here is a condition. So if we look at this, that means that my ratio of probability analysis requires that I look at the intersection of A and B occurring over what my new sample space or my new denominator is going to be the probability of A. So I'm only looking at a subset here, okay? So let's look at an example of this. And then I'm going to also give a little review as to how we determine what rule to use using different things. So I'm going to go ahead and start with a little two-way table. I'm going to need a new sheet, so I'll make a new two-way table here. So remember, my two-way table is going to be comparing two different things that are in a binary situation, yes, no situation. And we're going to go ahead and see what we get. So I'm going to go ahead and say I'm looking at, let's call this male and female. So notice that this is still binary because female is not male. So one is yes, one is no. And then I'm going to look at, let's say that we surveyed a total of 78 people, male and female, and we asked them, what type of car do you drive? And let's just say we're looking at a Japanese car representation. So some of them said Honda and others said Toyotas. Okay. And so of this, they said there was a total of 41 males in the study and 37 females. Now, do you see how this adds up? 41 plus 37 gives me the 78. And of those people, we're going to say that 35 chose Honda. And what do you think that's going to make for my Toyota driver? So if I look at the difference there, that's going to give me 43 Toyotas. Okay. And in this study, again, this is just a scenario that I'm going to use to make sure that we can analyze the probabilities. In this scenario, we're going to say that there was 30 females that drove Toyotas, which meant that there were 7 females that drove Hondas, and if there are 7 females and there's a total of 35 Honda users, that means that there was a total of 28 male Honda drivers, which means that there was a total of 13 male Toyota drivers. Okay, now this must be able to sum up in all directions. Let's see. 28 plus 7 gives me 35, check. 13 plus 30 gives me 43, check. 41 plus 37 gives me 78, awesome. 28 plus 13 should give me 41. 7 plus 30 gives me 37, and 35 plus 43 gives me 78. So that's what my two-way table looks like. Next, I'm going to be asking, okay, now that we have that, very first rule I'm going to ask is, I'm going to show off the addition rule first. And so some of the words that you can pick up for addition rule. Addition rule clues is going to be either and or, okay? And then multiplication rule clues is going to be and then, okay? And then conditional rule clues is going to be the word given or with the condition of, okay? So these are context clues that we're going to use to figure out this. So let's start with our first example. Example number 1 says, what's the probability of selecting a female or a Honda driver? Okay, so the very first thing we're going to do is we're going to go in there and search for those context clues. So the word or means addition. So we're going to go ahead and use that rule. So what's the rule? The addition rule. I'll put that in. Do I have orange? I do. Let's see how my orange looks on the screen. There we go. Okay, so we recognize that the addition rule looks like this. The probability of event A or event B occurring is equivalent to the sum of the probability of event A plus the probability of event B minus the intersection, the probability of their intersection when they both occur. Okay, so let's go ahead. Again, remember, given the problem, I annotate the context clues I know. I recognize the rule I'm going to use. I'm now going to tailor this rule and put it into the context. So let's see. I'm going to let A be the event being a female. Okay, and I'm going to let B equal a Honda driver. So now I'm going to go ahead and replace the rule in context with the scenario that I'm analyzing. So that gives me probability of choosing a female or a Honda driver is equivalent to the probability of choosing a female plus the probability of choosing a Honda driver, subtracting their intersection probability. So the probability of both a female and a Honda driver. Okay, so given that, what's the probability of choosing a female? Okay, here's my female analysis. So probability is going to be 37 out of 78. What's the probability of choosing a Honda driver? So here's my Honda analysis. That means 35 out of 78. But again, I have to subtract that intersection. What is the probability of choosing a female Honda driver? That's 7 out of 78. Okay, so 37 plus 35 minus 7. 37 plus 35 minus 7 gives me 65 out of 78. And 65 out of 78 is equivalent to 0.8333. And again, remember, I need a total of 5 numbers after the decimal because I'm going to need that 5th number to determine the 4th decimal because, again, this needs to be converted into a percent. So that's going to give me 83.33%. And my final answer is going to say the probability of selecting a female or a Honda driver is 83.33%. Okay? So that's example 1. Okay? Let's look at another one. Example 2. Let me just cut this off for the sake of my notes. What's the probability of selecting a female given that she drives a Honda? So notice again, context clues. Context clues. What's the context clue? Given. And given means conditional rule. So I'm going to use the conditional rule. So the conditional rule says probability of B given A is equivalent to the probability of A. Where am I? And B. Sorry. Let me write this all over. Probability of A and B divided by probability of A. Sorry, let me just rewind and put that off. Okay. So again, I need to understand what is the context of what event is what, okay? So who's the condition? A is the condition. What is my condition? My condition is a driver that's a Honda. So here, my A is the Honda, that's the condition, being a Honda driver. And my B is now the female. Okay, I'm now going to put the rule into context. So that means the probability of choosing a female given that she drives a Honda is equivalent to the probability of having a Honda and a female, right? Honda driving female, divided by probability of driving a Honda. Okay, so let's see. What was the probability of a Honda driving female? Honda driving female, 7 out of 78. And what's the probability of driving a Honda? Driving a Honda was 35 out of 78. Now recall that when I divide fractions, the rule indicates the following. So dividing fractions rule says if I have a fraction and it's being divided by another fraction, then I don't touch the first fraction. The first fraction stays as is. Division turns into multiplication. And my second fraction flips. So I now have D over C. I have the reciprocal. So, and then now that simplifies to top, top, bottom, bottom. Another rule, AD over BC. Okay? So just a little tangent rule because I have a complex fraction here, a fraction dividing another fraction. So that's what we're going to simplify now. So this equivalates to 7 over 78 divided by 35 over 78. Again, first fraction stays as is. Division turns into multiplication. And the second fraction flips, which means I have 78 over 35. And top, top, bottom, bottom means I am left with 7 out of 35. So the probability of choosing of a female given that she drives a Honda is 7 out of 35. So that gives me 0.20. So probability of choosing a female given that she drives a Honda is 20.0%. So again, probability of selecting a female given that she drives a Honda is 20%. Okay, so let's go quickly over an overview of the expectation here. First thing, context clues are identified. Those context clues then allow me to see which rule I'm going to use. So once I recognize the context clue, I state the formula of the rule I'm going to use. I then also recognize what each event represents depending the context. So as you can see, both contexts were very similar in questioning, yet the analysis and the representation of event A and event B are very different. So be very careful for that. So recap, context clue is identified, then the rule is identified. I identify how I'm going to represent event A and event B, and then I rewrite the rule in context of the situation. So I recognize A and B events. I now write it in the terms of the context. And then I do the analysis based on the rule. And now notice my probability is first given to me as a ratio. It must be turned into a decimal, and that decimal must then be turned into a percent. And then my final step is actually answering the question. Literally, you're just restating the question with the percent given as a final answer. Okay? I'm going to go ahead and move on. I still need that two-way table. So my next question is going to be a continuation of this one because I'm going to also showcase, let's see, example 3. What is the probability of selecting a Honda driver given that she's female? Okay, so again, context clue given means I'm going to use the conditional rule. So the conditional rule indicates probability of event B given event A is equivalent to the probability of event A and B divided by probability of event A. So I'm going to recognize what's my event A, what's my condition. What's my condition? Given that is the condition, so that is my condition. So I'm going to let A be female, and my B is now the Honda driving situation. So notice 2 questions looking at the same type of events, but now the conditions flipped, and so my analysis is going to take a whole different turn. So now I've indicated I found the context clue, I recognize what the condition is, I've applied the rule, recognize what A and B are. Now I'm going to go ahead and put the conditional rule into context, which means what's the probability of selecting a Honda, right? Honda driver given that she's female. Okay, so that means I'm choosing probability of female and Honda driver divided by now probability of female. Okay, so now we're going to put that into its analysis. So what's the probability of choosing a female driving a female Honda driver? Right here, 7 out of 78. So 7 out of 78. And what's the probability of female? Female now, 37 out of 78. Okay, that's all I need now. I can cover that up. I don't want to confuse you anymore. So now I'm going to go ahead and put this analysis. So remember that this is the same as 7 out of 78 divided by 37 out of 78. First fraction stays as is, nothing gets done. Division turns into multiplication, and I'm now multiplying by the reciprocal of the second fraction, which is 78 out of 37. I'm going to apply the top, bottom of fractions, and that's going to give me 7 out of 37. So 7 out of 37 gives me 0.18919. 0.18919. Okay, which tells me that the probability of me selecting a Honda driver given that she's female is 18.92%. So the probability of selecting a Honda driver given that she's female is 18.92%. Okay? Now, the biggest thing that you need to see here is notice that here, probability of choosing a female given that she drives a Honda is 20% versus the probability of choosing a Honda given that it's a female is 18.92. So what's the biggest takeaway here? The conditional rule is not equivalent in this format. No, it is not equivalent. The probability of event B given event A does not equal the probability of event A given event B. They are not equivalent, okay? Very important. I'm going to go ahead and also check now the multiplication rule. So the multiplication rule has either or clues like and then or replacement. That's another clue word, okay? With or without replacement. So with or without, okay? With or without replacement. That's really important. So let's go ahead and look at something. What is the probability of selecting two males that drive a Toyota? Okay. And my first example is going to say without replacement. And my second example is going to say with replacement or replacement allowed. Okay. So we're going to look at this and we're going to see, let's see. We're going to see, this is going to be multiplication rule. Do I have another colored pencil? Probably. Let me see. Okay. So with replacement means multiplication rule. Okay. And my multiplication rule okay. Notice two males that drive a Honda. That means males that drive a Honda. So that means I'm going to do A is males. And Toyota. Sorry. And B is Toyota. So males that drive that is going to give me this. Okay. Right there. And the rule is going to say P of A times P of B given A. That's the rule. So now we're going to put it in context. So What's the probability of selecting 2 males, right? And a Toyota that drive that. So male Toyota, okay? So we're gonna go ahead and do this. So this is gonna give me probability of males with the Toyota part, right? Times probability of Toyota given males. Okay? So I'm going to prove this. So first I'm going to prove this, and then I'm going to prove the 2 part, okay? So right now I'm just proving males that drive a Toyota. That's the first thing I'm doing. Okay. So what's my probability of male? Male is 41 out of 78. Okay, and I'm going to be multiplying, so that's why you see, parentheses. Now, what's the probability of selecting a Toyota driver given that they're males, right? So, Toyota driver given that they're males. Remember the condition? The condition is now my sample space. So I have 13 out of 41. Okay, so now top, bottom gives me 13 out of 78. So notice 13 out of 78, 13 out of 78 is the males. If you don't believe me, that is the probability of just this intersection, yes? So now let's talk about this without replacement. I'm going to use this ratio and I'm going to apply it again without replacement. So that's going to mean, what does without replacement mean real quick? Sorry, let me put that there. Replacement here does not mean like you substitute. Replacement here means this is my sample size. Once I choose something, I'm able to put it back. That's putting it back, replacement. So that my first selection, I choose it, awesome, put that thing back into the sample. And then my second trip, I choose again, and the sample size never changed because it got replaced. Now, without replacement means, let's say I have a bag of 10 marbles, and I choose on the first one, and I don't replace that marble back. I do not put it back. That means that my next section, now instead of considering it out of 10 marbles, it now gets considered out of 9 marbles. So that's the same thing that's going to happen here. So I'm going to ask, what is the probability of selecting 2 males? So now I'm going to look at 2 males that drive a Toyota without replacement. So without replacement means that's the first one. Okay. And what's my second one? So I'm still kind of using this rule because 2 males means I first choose the first male, then I choose the second male. Okay. And then given that I already chose one, I'm not replacing. What's my new probability? My new probability is 12 out of 77. Why? Because first I chose a male that drove a Toyota, so that was 13 out of 78. That potential is no longer there. So now I don't have 13, I now have 12. I don't have 78, I now have 77. So that right there is the probability that I'm going to get. And let me go ahead and find what that's going to give me. 156 out of 6,006. So let's see. 0.02597. 0.02597. So I'm going to put this on another sheet just because of space. Let me just take this off. The probability of selecting 2 males that drive a Honda, a Toyota. So remember, this becomes 2.60%, is 2.60%. So let's recap real quick. I used the multiplication rule to recognize and prove that the intersection, A and B, is still equivalent to that. Now, this is the the males that drive a Toyota probability right here. Now, if I'm asking for 2 of those, then it becomes a product of those probabilities. However, when I don't replace, that means I have 13 out of 78. And since I didn't replace, that possibility of male driving Toyotas is decreased by 1, but so is my sample space. So then it's this product here gives me this ratio that converts into this decimal, that converts into this percent, and then it gives me my answer that the probability of selecting 2 males that drive a Toyota is 2.60%. Okay, now let's talk about with replacement. So with replacement means I choose that person, and then that person goes back into the pool and they're still part of my second selection. So with replacement are independent events, which means it doesn't mess with my denominator. The likelihood is still uniform, okay? So with replacement, so that means that I'm looking at the probability of choosing 2 males is going to give me, once again, 13 out of 78. That's the first selection. How about the second selection? The second selection, that person got back in the pool, is still going to be 13 out of 78 because the likelihood didn't change as that person went back into the pool. So there's still a possibility that I can choose the same person. Okay. So I have 13 times 13 is 169. And 78 times 78 gives me 6,084. This ratio converts into 169 divided by 684, 0.02778. And this converts to 2.78%. So the probability of selecting 2 male Toyota drivers, I must specify with replacement. I must specify that is 2.78%. Okay. So that concludes my video. If you enjoyed, stay safe, everybody.